We now move to our 8th session of the conference, the Bioeconomy Blueprint, an important conversation on building a sustainable and resilient bioeconomy for the future. So let's get started. Let's jump straight into it and invite our moderator on stage. Ladies and gentlemen, please put your hands together for Dr. S.S.V. Ramakumar. Audience, can we please have some cheer coming from all of you? Thank you so much. Thank you. Let's welcome our panelists, Dr. Sanjukta Subudhi. Welcoming you on stage, ma'am. A round of applause for the lady. Surendra Singh. And Snehalkumar Suryawanshi. A very, very warm welcome to all our panelists. With this, I hand over the session to our moderator, Dr. S.S.V. Ramakumar.
Good afternoon. I think post-lunch, attracting your attention is little tough, but I'm well equipped to grab your attention in this session. With the power of my fellow panelists who are here. They're all diversified panelists with diversified expertise, but common theme and thread that connects all of us, all four of us who are on the dais, is improving the bioeconomy and also improving the economic viability of ethanol economy, so to say. Because we are all concerned with ethanol. Since yesterday onwards, we have been talking about ethanol, various aspects of ethanol production, feedstocks and all. So it's no different in this session also, but you'll get some new dimensions of how to improve the ethanol economy. Let me first introduce my panelists, then each one of us will give some initial comments. After that, I'll go around the table and ask some interesting questions. I hope which are the questions that are nagging even your minds, revolving this concept of bioeconomy. So let me introduce the panel. On my left, first is Dr. Sanjukta Subudhi. She is the Senior Fellow and Associate Director. I know her for the past 20 years. She is Senior Fellow and Associate Director at the Energy Research Institute. Earlier it was Tata Energy Research Institute, TERI. Working all through her career around this first generation, second generation ethanols, dishing out new molecules which can be exploited as value-added products around this theme. Welcome, Dr. Subudhi. Next to her is Mr. Surendra Singh. He is coming, he is the business head of the big group. It's not the adjective, but it's the name itself. Big group is the name of the company. So he is the business head there with 29 years of experience in dealing with all kinds of industrial gases and also most importantly the carbon dioxide, which is a common thread for the entire sugar industry, entire ethanol industry. So he is having a lot of insights to give you on CO2, on carbon dioxide. And my extreme left is Mr. Suryawanshi. He is the head of Cleantech technology at Alfa Laval, the most popular and well-known engineering giant that in one or the other facet we all are touched by the exploitations of Alfa Laval. So he is from the engineering side. So what are we going to talk about in this next 30 minutes? See, improving the ethanol economy. We all know, I think this morning Honorable Minister Nitin Gadkari and many other speakers must have actually sang paeans about ethanol, in the sense even no less than Honorable Prime Minister very recently made a very appreciative remark about ethanol. Because of ethanol, the war-like situation, India could not face so much of problems as far as energy is concerned, because ethanol played a big role in terms of ethanol blending to gasoline, and we could able to weather some of the supply disruptions from the Middle East and West Asia. So we all know that since 2014, starting from less than 5% of blending in gasoline, ethanol blending has reached to 20, and today we are talking about, only yesterday Bureau of Indian Standards, yesterday or day before yesterday, they have released new specifications for higher ethanol blends in gasoline. And government has already announced E85. Niti Aayog is working on the roadmap for E85, and we listen quite a bit of preparations that are being underway by oil marketing companies. By the way, in my previous dispensation, I belonged to Indian Oil. I was director on the board of Indian Oil. For 30 years, I am a lifer in Indian Oil. So oil industry stories I keep telling you during the course of this, this discussion. So I'm not talking about ethanol production or sugarcane based ethanol production or grain based ethanol production, that you are all experts and many people have talked about. But can we look beyond ethanol? That's the question that I am going to address in this session. Because ethanol by itself is not a very economic proposition. And do you want to improve your bottom lines? Do you want to diversify beyond ethanol? That is what exactly we are going to do. And I am also a career scientist, worked at the Indian Oil R&D Center. So I also sincerely believe that from biomass, it's not only ethanol, and there is much more beyond ethanol. While you produce your ethanol, you can produce many value-added products. And I am not talking about the first generation ethanol. The first generation ethanol is the ethanol that most of you are producing as sugar industry players, from sugarcane molasses, sugar juice, or from maize. Today the new kid on the block is maize, and so we are all enthusiastic about maize and sugarcane ethanol. But I am talking about, there is another rich biosource that is waiting indigenously. Every year this country produces 228 million metric tons of bioresource, bio-waste, biomass waste in terms of agri residue, and your own industry produce a residue called bagasse, which I was talking to some of the experts during the lunchtime. You are very gainfully using it for power gen, but beyond power gen, bagasse is estimated to be surplus in the sugar industry. So can you do something with this bagasse? That is the question that we are going to address. So I belong to a company currently called AM Green, which is the owner of a global technology which can convert any and every type of lignocellulosic biomass. Scientifically, all these biomasses, agri residues, bagasse, everything is known as lignocellulosic biomass. The name itself indicates that each of these biomasses, they contain lignin and they also contain cellulose. That's why they are known as lignocellulosic biomasses. And there is a technology, there is a little complex technology compared to fermentation that you are all familiar with. There is a little complex technology which can separate lignin, which can separate cellulose, and cellulose can be proceeded to produce ethanol, but this ethanol is going to be much more valuable ethanol because the carbon intensity of the ethanol that is produced from lignocellulosic biomasses is extremely low. I can give you some numbers to qualify my statement. Gasoline's carbon intensity is 94. That is the benchmark carbon intensity. And compared to 94, your first generation ethanol from sugarcane molasses, sugarcane juice or maize for that matter of fact is 50% lower. Very good. First generation ethanol. So it is 50 carbon dioxide equivalent per megajoule of energy. That is the exact unit of carbon intensity. But if you produce the same ethanol from lignocellulosic biomass, the carbon intensity can be as low as 5, mere 5 units. Or it can be, if you use renewable energy instead of normal grey electricity, if you use renewable electricity, then it can be carbon negative. Your ethanol can be carbon negative. So this is the most precious ethanol. If you want to export your ethanol to European markets, hypothetically speaking, then your sugarcane based ethanol cannot be exported, because India by 2030, even after blending 30% or 40% of ethanol in gasoline, we are going to be ethanol surplus country. So you would like to definitely explore the export markets, and if you want to export to European markets, which is a large market, European Union, then you need to focus on carbon intensity. And the carbon intensity of your ethanol can only be reduced by converting lignocellulosic biomasses. Your own bagasse can be converted into ethanol with very low carbon intensity by using these technologies. The technology that we hold today, we can license it to anybody globally. This is a technology called Chempolis technology. This is a Finland-based technology which is acquired by an Indian company called AM Green, to which I currently belong to. But I am not going to promote this technology or anything in this. I am going to close my opening remarks. Apart from producing such a low carbon intensity ethanol, this technology pathway can also give you some very value added products. Lignin. Lignin is on par with ethanol in terms of yields. And this lignin is a very rich polycyclic aromatic phenolic molecule. I am a chemist, so pardon me, inadvertently I speak some chemistry. So it is a polycyclic aromatic phenol, and this polymeric bioresource can be fragmented into various value added products. There are 20, 30 value added bioproducts can be produced using this lignin, so that all these can constitute a newer dimensions of bioeconomy. So my essence of my opening remarks is that there is much more beyond ethanol from the same sugar industry or from same available biomass. You can produce many more biomolecules, and you can constitute newer dimensions, and you can actually explore newer facets of bioeconomy. I'll stop here, and I'll invite my fellow panelist, Dr. Sanjukta, to extend this argument on bioeconomy and new molecules.
Very good afternoon. Thank you so much, ChiniMandi and organizing committee, for providing this platform. I'm glad to speak at this forum. The theme of this forum is Bioeconomy Blueprint. Very, very interesting theme. If you see the contribution of this bioethanol to this India's bioeconomy platform, could significantly escalate. If you see the bioeconomy growth over last 10 years, you see around 16-fold growth in the, mostly that comes from the bioindustrial segment, and in that bioindustrial segment is bioethanol is one of the core molecule. So the bioethanol we are focusing, the raw material is sugar. So I'm a microbiologist. This sugar is very much favorite food for almost all of the microbes. Having said that, this is a very good feed for ethanol. Ethanol is produced by microorganisms through fermentation pathway. There are also portfolio of biomolecules, having said that a diverse array of chemicals that can also significantly contribute to the chemical segments, because petrochemical segment is also focusing on use of fossil based. So to name few of the chemicals like lactic acid, then you focus butanol, and the more important is very high value chemicals, that is a specialty platform chemicals. If you see the butanediol, propanediol, succinic acid. So these are the portfolio of molecules should India's biomolecule basket should also consider focusing on development of this portfolio of molecule. So the important crux is identifying the right type of microbe. The entire process is almost in a way the same, the fermentation process. Even the same infrastructure facilities for the upstream part can be used to produce these diverse molecules, and the microorganisms is different. And the innovation is key. When you say the growth, the innovation must continue. So it is essential that we also focus or expand our biomolecule basket to produce or co-produce the biofuel, ethanol, also biochemicals. One of the key aspects I would like to touch, because sir has spoken about the 2G ethanol. So if you see for any process, the mass balance works. For 2G ethanol, for agriculture residues and the forestry residues, whatever the woody biomass we consider, around 20 to 30 or 35% is a lignin. We consider this as a challenge because the pre-treatment adds on some cost, and that's why the 2G ethanol is expensive. But if you see, the opportunity lies in that segment itself. Lignin is a very good raw material for a very, very expensive chemicals. To give few examples, you talk of vanillin. Since lignin fraction is a very good feed for valorization through using this microbe to produce vanillin. Vanillin is one of the very expensive pharmaceutical chemical one can sell in very high cost, around 1,500 to 2,000. I mean, the cost of this vanillin molecule is very, very high. So some of the technologies which are at lower TRL, one must focus on in scaling of these technologies. There, it is very much essential that the industries and academia come together. Similarly, if we focus on lactic acid, so these are several bulk, especially the specialty biochemicals I would like to focus here, because the bioeconomy segment will go drastically high, because bioethanol could contribute, and if you focus on same sugar, and the identified different microbes, the same infrastructure facility use and produce high value molecule that can produce the, generate the revenue as an added part. Similarly, for the lignin, one can focus on the carbon fibers, and one segment I would also like to say that lignin can be converted to furfural, and that furfural can cater to the sap production. These are the different pathways. It is very much essential to map those pathways and integrating these pathways. And similarly, for the shipping sector, if you see, these lignin fractions can convert to the bio oil, and that can go for the blending with the marine fuel. So it is very much essential that we can focus on diversifying our basket of these biomolecules. And sir, the 2G ethanol, when we say the silage which is coming from the 2G ethanol plant, that still contains 0.5 to 0.6 around the COD. So one cannot discharge that. If you want to focus as a zero waste liquid discharge, then that silage is a very good feed for biohydrogen production. Again, is the same facilities, the fermentation mode. So water is being, we are recovering the organic fractions, and the water is coming out clean. So these are the set of pathways one must focus on mapping the pathway and what is the best molecules that we can recover from the input feed. Sometimes it happens that the biofuel production, let's say ethanol cost is some amount, but the co-product that we produce, that the cost of that co-product, selling cost of the co-product is very high. So one such molecule is the butanediol. If we focus on it, is a very high expensive molecule. It is used for the MEK and butadiene. India imports 80 to 90% of this molecule. So same sugar can also go for the production of such type of high value chemicals. So it is very much essential that we focus on diversifying our biomolecule. So using same set of infrastructure facility, but open our mind to explore all these opportunities, so that the chemical segment could also see the light of the day to substitute some of the molecules with the greener molecules.
Thank you, Dr. Sanjukta, for giving a kaleidoscope of opportunities around the biomass other than ethanol. But I'll come back to you to concentrate on you and give a little more detail on one or two opportunities out of this bioeconomy. But I'll come back to you after the other two panelists also make their intervention. Let's go to Mr. Surendra. Sub, I think the entire ethanol industry is here, and हम सब ने वो एक सर्फ का एक ad देखा है, कोई I don't know which brand is that, but एक famous advertisement है, TV commercial है, उसमें ये बोलते हैं कि दाग अच्छा है. तो हमारे सारे इंडस्ट्री का एक दाग है कार्बन डाइऑक्साइड. हम इथेनॉल प्रोड्यूस करेंगे तो ज़रूरत से we will produce copious amounts of carbon dioxide. But today most of the carbon dioxide is being vented out into the atmosphere, or very low hanging and low value addition is being imparted to this CO2, because we feel that CO2 is not very good. But I think Mr. Surendra is going to give a different dimension and different twist, that carbon dioxide is good, daag acha hai. So how carbon dioxide is good, and what kind of economics that one can really realize by properly capturing and utilizing the carbon dioxide coming out of ethanol industry. Please give your account.
Thank you, sir. So the important point is CO2 is not waste, as you mentioned. CO2 is not waste. It will contribute a lot for your variable expenses on a daily basis. We are having, I have seen from last so many years, this is the purest carbon dioxide available in the market now, from last 5-6 years, when the ethanol industry has grown up and it is on a very right path. However, the investors, those who have invested their money in the ethanol plant, but not in CO2. They are having a thought that this is a low value product. No, it is not low value product. If you go through the history, how to produce the carbon dioxide, this is the purest form available in India. And reliability is quite high. If you talk about 2021-22, there was the reliability issue. However, the reliability of carbon dioxide in these days is very high. But the synchronization is a challenge between the ethanol manufacturers. Like if there is any shutdown, the user cannot stop the plant. They have to get the carbon dioxide. So it is not a waste. Whenever we are planning to establish a new investment of ethanol plant, we must plan properly carbon dioxide plant as well. It is a very low cost to you, and the realization would be whatever the variable cost you have on a daily basis in your ethanol plant, it will contribute a lot. The CO2 will contribute a lot. As well as the beverages segment is the only not segment. There are a lot of segments, and the government of India is also working with some of the industry where the carbon dioxide requirement is quite high, so that they can enhance as well as increase the yield of their production. I'm talking about the fertilizer units, the PSUs, as well as the private fertilizer manufacturers. They're having a lot of requirement of carbon dioxide for their process, which increase their yield. So CO2 is not a waste. I've seen so many people are still venting carbon dioxide in the market, in the air. Please extract and put the standard plant. It should be safe. Seen there are certain plants, they have put it the low category plant and face a lot of challenges of reliability, quality, safety, which is not acceptable by the users. They are visiting to the plant, they are visualizing the activities. So we should have the proper standard, and carbon dioxide give the lot of revenue on a daily basis to you. Over and above, if you talk about beverages, the yearly growth is somewhere around 10 to 12% of CAGR. The investment of carbon dioxide plant is ROI, I am assuming that it is somewhere around 4 years. And the PNL would be somewhere, I can say the OP would be somewhere around 28 to 32%. So this gives the lot of benefit to you on a daily expenses. So my request is we should put the standard plants, and we are having a lot of expertise in terms of the technology, in terms of the people, sales. We are the highest supplier of carbon dioxide in the beverages and the other fertilizer plants as well, including industrial segment. And if you talk about the Maharashtra and some part of the Gujarat, the major automotive manufacturers are available over here. So CO2 sales is not a challenge. However, there is a challenge of approach. We are not approaching them. Maybe they are next to your door, but the challenge is there is no approach to them, and they are procuring carbon dioxide from the maybe some long distances manufacturers. So please, if you have any challenge, we can support on that. We can not only, we are having so many plants, establish the plant in carbon dioxide and give the very good revenue to you. I hope I have answered your question, sir.
Thank you. Thank you for making it aware that CO2 is also a very value-added product, and you can derive some value out of CO2 which we are otherwise venting it out in the atmosphere, especially from ethanol industry. So we'll come back to you on cost of capture, how best you can optimize these costs, and what are the large commercial scale projects that we can work out based on the captured CO2 from ethanol. All that will come back to you. Let me now invite Mr. Suryawanshi. So there's a big role of engineering in all these, in this industry, in ethanol industry, whether it is first generation or second generation. How do you see, because from the CPCB, State Pollution Control Boards, or even Central Pollution Control Board, zero liquid discharge is a mandatory requirement for any of these industrial establishments if you want to get the white category status. So how much, what is the role of engineering, and how Alfa Laval is perceiving this aspect?
Yeah, hi, I come from Alfa Laval. We are truly an engineering company headquartered in Sweden, and primarily we focus on sustainability and climate change. We offer clean technologies. It's a very right question, SSV Ramakumar sir. We look at this industry as we wanted to make them aware about the problems what they have in terms of energy efficiency. And we as an organization, before going to any point, we deep study. We have at Alfa Laval industry managers who understand your processes, your difficulties, and way the which it can be solved energy efficiently. Now, if I talk about zero liquid discharge, industry, some of the sugar mills, some of the biorefineries or ethanol producers looking at ZLD as a compliance-based mechanism. So I'll say from Alfa Laval that it's not an atom in your utility. If you engineer the zero liquid discharge very properly, it's going to give you back valuable resources. It is also going to help you in reducing your CO2 footprint at the plant level. And complete optimization of zero liquid discharge systems is going to help you in making top line and bottom line. Again, coming back to the ethanol as a subject, there are technologies available with which we can make 2G ethanol most sustainable, and cost economics can be converted into profits. So from Alfa Laval, our industry managers can get in touch with you and we can solve your problems. I'm cutting down on my answer because we are short of time. We can see only 2.25 minutes are left, and I'm going back to SSV Ramakumar so that he can deliberate more on this topic.
Thank you very much. So let me come back to Dr. Sanjukta. So you have given a wide variety of opportunities of biomolecules which can be derived from all sorts of, but this industry generates bagasse. So from bagasse also I know, I have analyzed bagasse thoroughly, analytically. Bagasse also contains 30% of lignin, to the tune of 30% of lignin. So from this lignin, which is there in bagasse, how can you derive biofuel? Say for example, marine fuel. And also in the morning also there is a lot of interest on polylactic acid from the sugar industry. That is another diversifying pathway. So can you give little more details of what kind of pathways, how mature these pathways are, the PLA as well as the bagasse to lignin, lignin to marine fuels? Because marine fuel today, maritime industry is also big market, and green marine fuels is the need of the hour to meet the MARPOL compliance. So be quick. I think already there is a bell has been rung, and I'll ask one more question to another panelist.
Yeah. Thank you, sir. So there are multiple pathways, but in the interest of time, I will just focus first on the bagasse, the lignin part. Sir, lignin is a very good feed that in my opinion, we can also focus on lignin, convert to the through the hydrothermal liquefaction or the bio oil. That will cater, because the shipping sector is not having enough of greener molecule. Going forward, biodiesel is the drop-in fuel that we are focusing to use for blending, but we know that biodiesel raw material is not available enough. So the lignin can be is a good suggestion to consider lignin for conversion of this bio oil. That bio oil will go for blending with the maritime sector. And coming to the SAF, then lignin take it to the furfural and convert to the SAF. And if in the fermentation path, I suggest for the vanillin production, so the fermentation route. These are the three major molecules is what we suggest, so that the overall process can be cost economical. For the lactic acid, the technology is already, sir, TRL 8 and 9, and we see a great market for lactic acid, because that can cater to the production of polylactic acid, that can address the plastic pollution. Apart from that, sir, lactic acid is a huge demand in cosmetics and other segments, also in the pharmaceuticals, and the technologies are matured. So we can focus as an immediate next biomolecule, lactic acid as a next biomolecule. We should focus on taking those technologies at commercial scale. And in the interest of time, I will complete, but I would love to take queries. Yeah.
Organizers are hinting me. So friends and distinguished delegates, that beyond ethanol, you can look. Sky is the limit. Your own bagasse, which is a waste, and which you are now generating very, very low value power, you can still manage your power generation, because the renewable energy costs are coming down. Today, renewable energy cost, believe me, is cheaper than your coal-based electricity. So wherever possible, wherever there is a CTU connectivity, central transmission line is passing through your sugar industry, draw the renewable electricity, replace with all this bagasse based power. Use this bagasse. Bagasse is a rich bioresource, and you can go all the way up to sustainable aviation fluids, and the entire global market is available to you. So beyond your own state, beyond your own country, you can really focus the global markets of marine fuels, sustainable aviation fluids, many value added chemicals, and carbon dioxide, the pure carbon dioxide, you can capture it and you can convert it into green methanol, and the plants can be optimized through value engineering by engineering interventions. So with this summary statement, I conclude this session, and I hope you have enjoyed and learned some new opportunities beyond ethanol. Back to the organizer.
Thank you so much, sir. I have to say, you've been extremely passionate as a moderator, because even during the lunch hour, he came and checked his slot, his timing. He checked everything with me. So it just shows so much of sincerity and so much of passion from your end. We really, really appreciate it. Thank you so much to our wonderful moderator and to our wonderful panelist. I would quickly like to request Mr. K.S. Hosalikar to please once again join us on stage and felicitate our entire panel. Our wonderful moderator, Dr. S.S.V. Ramakumar. Can we please felicitate our moderator? We can come to the center. आप बीच में आ जाइए sir. हाँ. Hosalikar sir can be the center and then we can all keep collecting our mementos. Let's please welcome Dr. Sanjukta, Subudhi. Surendra Singh. And Snehalkumar Suryawanshi. And can we all quickly come together for a group photograph?